Our next topic is equation of motion in polar coordinates. Means that x equals to r cos theta and y equals to r sin theta if a body of mass m with center c having radius r moving some velocity. And in polar coordinates, x equals to r cos theta and y equals to r sin theta, and its velocity components x dot equals to r dot cos theta minus r theta dot sin theta, and y dot equals to r dot sin theta plus r theta dot cos theta. As we know that the particle is moving, it has only kinetic energy, which can be given as 1 over 2 m v square or 1 over 2 m x dot square plus y dot square. By putting these equations in equation 2, we will have t equals to 1 over 2 m and r dot square plus r theta dot square. Equation 3. As we know that in generalized form, Lagrange equation can be given as d over dt partial t over partial q dot minus partial t over partial q equals to qj, where qj is generalized force. Say equation 4. As we know that v square equals to r dot square plus r theta dot square, or v equals to just v equals to r dot plus r theta dot and theta direction, and r equals to r cap plus r theta cap. By differentiating with respect to r and theta, we have partial r or partial r equals to r prime, and it will be 0, and again we have partial r or partial theta equals to r and theta cap. Multiplying by f, we have partial r equals to f r and f. Both sides we have f r and theta cap. It can be given as qj equals to fr and qj equals to r f theta. So here we have two forces. Lagrange equation can be given as in terms of r and theta as d over dt partial t over partial r dot minus partial t over partial r, and with respect to r we have fr equation say phi, and with respect to theta we have d over dt partial t over partial theta dot minus partial t over partial theta equals to r f theta. Say equation 6. Now we have to differentiate or taking derivative equation 3 with respect to r theta and r, then theta dot and theta, and then by putting values we will gain our results. So first we will solve with respect to equation 5. Taking partial derivative of equation 3 with respect to r dot, we have partial t over partial r dot equals to 1 over 2 m2 r dot. Constant we have cancel m r dot, and d over dt partial t over partial r dot, we have m r double dot. Equation 6. Differentiating with respect to partial t and partial with respect to r, we have 1 over 2 m and 2 r theta dot square. By cancel we have m r theta dot square. So by putting equation 6 7 in equation 5, we have m r double dot minus m r theta dot square equals to fr, which is the first solution, and say equation 7. Now again we will differentiate with respect to theta dot. We have partial t over partial theta dot. Here we will get 1 over 2 m constant r square to theta dot cancelling, and we have m r square theta dot, say equation 8, sorry, and then taking its further derivative with respect to t, we have m r square theta double dot, say equation 8. Now taking derivative with respect to theta, we have partial t over partial theta equals to, and here is no theta, it means whole term is constant, and here we have 0 and equation 9. Now put equation 8 and 9 in equation 6, we have m r square theta double dot minus 0 equals to r f theta, or m square theta double dot equals to r f theta, which is the second required results, and say equation 10. So equation 7 and equation 10 are our required results.